call is now being recorded.
So today we will start unit 4. Unit 4. Uh, Today we will discuss about abrasive jet machining process. This is actually non-traditional machining process. All the machining process I have discussed previously. That was traditional or conventional machining process. These are non-conventional and non-traditional machining process. Okay, non-traditional machining (NTM) or non-conventional machining process. So in this process, actually, the material removed from the workpiece without direct contact between tool and workpiece. ओके मीन्स इसमें टूल एंड वर्कपीस का डायरेक्ट कांटेक्ट की जरूरत नहीं है विदाउट डायरेक्ट कांटेक्ट बिटवीन टूल एंड वर्कपीस material can remove from workpiece. Okay, clear?
Okay, sir.
Okay. So this abrasive jet machining was one of the non-traditional machining processes. Means, there are different non-traditional machining processes like water jet machining, abrasive water jet machining, laser beam machining. Okay, electron beam machining, uh, EDM, electro discharge machining, electrochemical machining. All these are non-conventional machining process. In this process, there is no need to direct contact between tool and workpiece. Okay, so there is another media, and by this media, the material will be removed from workpiece. Okay, like in this case, abrasive jet machining. So here a abrasive particle. These are just see here. This is the nozzle, and so this one actually the nozzle, and from this nozzle a high velocity abrasive particles influenced on the workpiece. So इसमें क्या हो रही है? एक abrasive particle. Under these abrasive particles at a very high velocity में क्या होगी? These abrasive particles influence on the workpiece. ये जो है यह workpiece है. Okay. And जैसे हाई वेलोसिटी पे abrasive particle इसी वर्कपीस पर इम्पेंस करेंगे देन द मटेरियल काट हो जाएगा जैसे ग्राइंडिंग कैसे होती है ग्राइंडिंग ऑपरेशन इज डन बाय in this grinding wheel some abrasive particles are there and those abrasive particles act as a cutting tool. Okay, like that, in this case also, these abrasive particles act as a cutting tool. Okay. अतः ये जो nozzle है, this nozzle actually directly not contact with the workpiece. वर्कपीस से डायरेक्ट contact नहीं रहेगा इसमें. इसमें जो abrasive particle है, वो abrasive particle high speed में और वर्कपीस के ऊपर इम्पेक्ट करेंगे and then वर्कपीस से वर्कपीस होगी वर्कपीस जैसे शेप है एंड साइज की जरूरत है उसके अकॉर्डिंग you can cut the workpiece into it. Okay, clear? Okay. So this abrasive jet machining, it is the material removal process where the material is removed by high velocity steam
Yes,
of
sir.
okay. So it material is removed by high velocity steam of air or gas or water एंड एब्रेसिव मिक्सचर उनसे इसमें जो एब्रेसिव पार्टिकल जो इंक्रीज हो रही है दिस एब्रेसिव पार्टिकल इज फॉलो एट ए वेरी हाई वेलोसिटी एंड हाई वेलोसिटी कैसे होगी बाय स्टीम अदर स्टीम ऑफ हॉट स्टीम ऑफ एयर और गैस भी हो सकती है एंड वाटर इनसे वाटर भी हो सकती है तो either water or gas or air में फ्लो होगा एंड गैस और वाटर के साथ एब्रेसिव पार्टिकल है जैसे जस्ट फिगर आ रही है ना तो जस्ट दिस फिगर जो पार्टिकल है दीज आर एब्रेसिव पार्टिकल्स these abrasive particles size of these abrasive particles is very less इसमें बहुत छोटा छोटा पार्टिकल होती है ओके एंड दिस एब्रेसिव पार्टिकल जैसे वर्कपीस के ऊपर हाई वेलोसिटी में उसको इम्पेल करेंगे देन क्या होगी वो आरपीस वहां से काट हो जाएगा जैसे सी आरपीस हाउ द आरपीस विल कट है ओके तो this is actually nozzle okay so from this nozzle this mixture of abrasive particles and gas or air or water uh, impinge on this workpiece at a very high velocity. Okay, and after impinging that means according to your requirement means किस type की shape है you can move this nozzle जो nozzle है you can move it and hello
Yes, sir.
okay अभी से आ रहा है साउंड ओके
Okay, sir.
बीच में नेटवर्क डिस्टर्ब हो गया okay so this is the introduction of basic definition. So what is the work principle and process principle of this abrasive jet machining? So so first क्या हो रही है abrasive particles so these abrasive particles increase on the workpiece at a high velocity. Okay. The abrasive particles is abrasive particles and increase on the workpiece at very high velocity and this high velocity actually carried uh, by either gas or water. Okay. These abrasive particles is carried out by carrier gas or air or water. High velocity stream of the abrasive is generated by converting pressure energy of a carrier gas or air to its kinetic energy, and hence a high velocity jet means जो high velocity means जो abrasive particle और इसके ऊपर impinge हो रही है at high velocity, यह velocity कैसे मिले? So this actually by just converting the pressure energy of the gas to a kinetic energy. Means जो गैस और एयर और वाटर कोई भी हो सकती है जो यूज करेगा वो दिस आर एट वेरी हाई प्रेशर. ओके, हाई प्रेशर में सिलेंडर में स्टोर किया जाता है. एंड व्हेन यू रिलीज दिस गैस एंड अदर गैस और एयर और वाटर जैसे रिलीज करूँगा तो एटा हाई प्रेशर में स्टोर किया जाता है. जैसे रिलीज करूँगा तो हाई प्रेशर में वो प्रेशर एनर्जी विल कन्वर्ट टू ए काइनेटिक एनर्जी. ओके, प्रेशर एनर्जी काइनेटिक एनर्जी कन्वर्ट होगी एंड और इसके ऊपर एक हाई वेलोसिटी से चेंज होगी. ओके, and a nozzle is used to direct the abrasive jet. Okay, means where you want to suppose means according to the different shape required shape of the product, you can travel or direct the nozzle. Okay, okay. So just to see here means if you like suppose this type of product is required, so you can travel the nozzle like this. Okay, this is nozzle. You can travel like this. Okay, and ultimately you will get this type of cutter, this type of product. Okay, metal cutting action by micro cutting as well as brittle fracture. मीन्स इसमें जो मेटल कटिंग होगी so this is actually micro level micro cutting and जो फ्रैक्चर सरफेस मिलेगी so these fractures are like a brittle type fracture. Okay, different from conventional sandblasting and the shot blasting process. Means, this process is different compared to the uh, conventional machining process like blasting and shot blasting. In this case, a finer abrasive grids, finer abrasive grids or finer abrasive particles are used, and the process or machining parameters are easily controllable. In this abrasive jet machining, you can control the process parameter very easily. It's like a pressure, speed, size of particle. Okay, okay. So this is the process principle. Means okay, so work the abrasive jet machining will work. So this one is actually nozzle. Okay, a nozzle. So just see in this nozzle, these are black spots are the abrasive particles. So these are actually abrasive particles. Okay, so these are abrasive particles. So these abrasive particles follow at a very high velocity. Okay, so high velocity abrasive jet around 150 to 300 meter per second. Okay, and it is meter per second. So at this velocity, this abrasive particles impinge on this workpiece. So this is actually a workpiece. So at this workpiece, these abrasive particles and a mixture of these abrasive particles and the gas or water, this impinge on this workpiece. इसमें strike करेगा. Okay. And as these abrasive particles impinge on this surface, then material will remove by what mechanism? Erosion mechanism. Okay, means यहाँ से जो और जो मटेरियल है, this material will cut from this surface. Okay, so abrasive and wire particles sweep out together, and this distance is called actually standoff distance. Standoff distance means this is the distance between the surface of the workpiece with the surface of the workpiece to the nozzle, means nozzle tip. Okay, means nozzle का जो tip है, so this tip of the nozzle to the surface of the workpiece means कितना distance से मैं abrasive particle को impinge कर रहा हूँ. So this is called stand off distance. Okay, okay. So just here means nozzle direct टच नहीं कर रहे, ये कुछ distance से और वैल्यू से मीन्स जो abrasive particle से abrasive particle impinge कर रही है. Okay, so see white color किया गया ना, so this is actually mixture of abrasive particles and gas, either gas or water. Okay, clear?
Yes, sir.
So now, what is the mechanism? So here the fine particles. Just see the size of the particles is around 0.025 mm. Okay, means how much less? So fine particles are accelerated in a gas stream. Okay, either air or gas or water. तो दिस ये फाइन पार्टिकल जो है वो एक्सीलरेटेड होगी. एक्सीलरेटेड मीन्स वेलोसिटी बढ़ेगी, वेलोसिटी ज़्यादा होगी. एक्सीलरेटेड मीन्स ये है ना, वेलोसिटी ज़्यादा होगी. सो फाइन पार्टिकल्स आर एक्सीलरेटेड इन ए गैस स्ट्रीम. ओके, गैस और इस टाइप की एक गैस स्टोरेज है, गैस सिलेंडर. So the in this gas cylinder, gas are stored at a very high pressure, and this actually pressure regulator means you can regulate the pressure. कितना means you can actually follow the gas, कितना gas flow कर रहे हो at कितना pressure, and this chamber is for mixing the abrasive particles and with this gas. Okay, so abrasive powder particle will supply from here. इसे supply किया जाता है, and in this chamber the abrasive particles mix with this gas. Okay, a gas at a high pressure. Okay, gas at a high pressure, and sometimes a vibrator are used to vibrate this chamber. Okay, this chamber है. Sometimes a vibrator is used to vibrate for that for mixing the powder material and any some vibrations. जैसे अगर उसको vibrations and से जो properly mixing होगी, then these particles can remove the material very effectively on the workpiece. Okay, so and after mixing this abrasive particles with gas at high pressure, then this uh, this mixing abrasive particle on this pipe. Okay, एंड इसमें एक कंट्रोल वाल्व रहती है, मीन्स कितना मैं फ्लो करूंगा, मीन्स हाउ मच अमाउंट. सो यू कैन कंट्रोल दिस फ्लो रेट अमाउंट. ओके, okay, and this mixer will this mixer will impinge on this workpiece. ये workpiece के ऊपर ऐसे स्ट्राइक करेगी थ्रू दिस नोजल. ओके, ये नोजल से, so this is actually nozzle. Okay, and this nozzle can be moved or direct, means transfer. You can so this nozzle can be transferred from this direction to this direction, and you can change this stand of distance also. So this actually stand of distance, कितना हाइट से मैं और मिक्सिंग को मिक्सर को ये कर रहा हूँ. Okay. So the particles are directed towards the focus of machining. As the particles impact the surface, it causes a micro fracture. Okay. So this is the mechanism. Means first fine particles mixed with this gas and accelerated by the gas stream, and this mixture will impinge on the surface, and uh, fine particles impact on the surface and it causes a micro fracture. Okay, means surface के ऊपर फ्रैक्चर होगी, माइक्रो टाइप, माइक्रो फ्रैक्चर. ओके, छोटा छोटा फ्रैक्चर मीन्स पार्टिकल वहाँ से surface से निकल आए. ओके, so this is just इसमें देखो छोटा छोटा पार्टिकल कर रहा है, so these are actually micro fracture. And gas carries fracture particles away. उनसे एंड जो जैसे जो फ्रैक्चर पर छोटे छोटे जो पार्टिकल फ्रैक्चर हो रही है जो वहाँ सरफेस के ऊपर, so these fracture particles carried away by the gas. जो गैस फ्लो हो रही है वो गैस क्या करेगी, वो छोटा छोटा पार्टिकल जो और सरफेस से फ्रैक्चर हो रही है उसको रिमूव कर देंगे. ओके. So these type of abrasives are used like aluminum oxide, silicon carbide, sodium bicarbonate, dolomite, okay, and gas bead, glass beads. These are different type of abrasive used in this abrasive head machining process. Okay. So this is the equipment, means block diagram for abrasive jet machining. It's, there is a air compressor is there. So this air compressor is used to compress the gas. इसमें जो गैस रहेगी, so to compress the gas creating at a high pressure. Okay. तो इसमें जो गैस रहेगी नीचे सिलेंडर के ऊपर, in this chamber, so first it compressed the gas in this chamber, so a high pressure will create. Okay. And this gas, and there is a pressure control valve, means how much pressure do you want. Okay. Filter is there. So 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 this is actually the pipe, from where the gas यहाँ से गैस आएगी. ओके. एंड दिस इज द मिक्सिंग चेम्बर. ओके. सो here abrasive particles and the gas at a high pressure will mix here, and this is actually the abrasive feeder. So pour the abrasive particles through this basin, and the abrasive particle will feed to this mixing chamber. ये जो mixing chamber है, यहाँ abrasive particle यहाँ feed होगी, and यहाँ abrasive particle mixing होगी. Okay. And जैसे mix से हो जाएगा, then this abrasive particles will come out from here, and this यहाँ एक valve है, so you can regulate the flow rate, pressure, flow rate and pressure also. And through this nozzle, this mixture of abrasive particles and air will impinge on this workpiece. Okay. So sometimes this nozzle can be travel according to the desired requirement of the workpiece. Sometimes there is a table, and this table can travel. जैसे अगर table को travel करूँगा, then according to the desired shape, the product can be achieved. Okay. So these are actually different main components of abrasive jet machining. So it means first gas propulsion system is there. So in this gas propulsion system, either air or nitrogen or carbon dioxide gas are kept there. Okay, oxygen in pure form is not used because of its violent chemical action with RPS chip or abrasive particles. Okay, and uh, pure ऑक्सीजन यूज नहीं किया जाता है ओके क्योंकि प्योर ऑक्सीजन जो एब्रेसिव पार्टिकल्स है ना आरपीस से जो मटेरियल रिमूव होगी तो क्या होगी उससे रिएक्शन हो सकती है ओके ऑक्साइड भी हो सकती है तो इसलिए प्योर ऑक्सीजन नॉट यूज and this gas propulsion is supply at 2 to 80 kg per centimeter square and can be stored in per centimeter square area में 2 to 8 kg gas can be supplied. Okay. Abrasive feeder, abrasive feeder or is the abrasive feeder की from here. So the abrasive feeder this abrasive particles are fed through a sleeve vibrating at 50 to 60 hertz. Okay, so इसमें एक vibrator रहते हैं and by vibrating this sleeve, the abrasive particles will feed. Okay, abrasive particle आगे feed means और जो मिक्सिंग चेम्बर है मिक्सिंग चेम्बर तक वह food means food होगी. Okay, by vibration. Mixing ratio is controlled by the amplitude of the vibration of the sleeve. Okay, means sleeve को uh, जो वाइब्रेशन हो रही है वाइब्रेशन का एम्पलीट्यूड अगर मैं ज़्यादा एम्पलीट्यूड दूंगा तो क्या होगी ज़्यादा अमाउंट ऑफ एब्रेसिव पार्टिकल्स फीड टू द मिक्सिंग चेम्बर ओके ओके so this actually the abrasive feeder अगर if we vibrate this abrasive feeder we vibrate like this okay so what will happen this abrasive particles will feed to this मिक्सिंग चैम्बर ओके मिक्सिंग चैम्बर पर फीड होगी अगर जो वाइब्रेशन में दे रहा हूँ अगर वाइब्रेशन का एम्पलीट्यूड मीन्स ऐसे if you increase the amplitude then this abrasive particles will hit more abrasive particles will hit okay and if you decrease the amplitude then less amount of particles will hit so by changing the amplitude of this vibration you can control the feed of abrasive particles okay machining chamber then this mix uh, equipped with vacuum dust collector. Then another component is pump. So here a crankshaft and intensifier pump are mainly used in the abrasive jet machine. Okay, means this type of pump, crankshaft and intensifier pump. The intensifier pump was the only pump capable of reliable creating pressure high. Okay, so this pump actually used for creating a high pressure. Okay, and this intensifier pump is a very high performance and the capability of creating a very high pressure. Okay, crankshaft pump are more efficient than intensifier pump because they do not require a power rubbing hydraulic system, ultra high pressure and more stroke per minute. Okay. Means actually this crankshaft pump is more efficient compared to the intensifier. But both these two type of pump, camshaft pump or intensifier pump are used for for creating high pressure. Okay. Then another part is the nozzle. So this is the nozzle. Just see. Just see this is a nozzle. So from this nozzle, how the abrasive particles will impinge on the workpiece. Okay. So this actually nozzle is required to direct the abrasive particles at a high velocity. Abrasive particles at high velocity on the workpiece. Okay, so this is a abrasive nozzle. So this abrasive nozzle is made by tungsten carbide, means 2030 tungsten carbide or sapphire. So these are very resistant to wire, means wire resistance, more high wire resistance. So and the important parameter is the diameter of this nozzle. Okay, so this diameter is 0.221. So means so according to this diameter, the close tolerance of the product can be made. Means जो product मिलेगी उसका close tolerance मिलेगी. Means ना fine cut is possible. Okay, हेड स्ट्रेट और एट राइट एंगल दो टाइप की होती है नोजल, हेड स्ट्रेट और एट राइट एंगल. लॉस ऑफ प्रेशर ड्यू टू बेंड, अगर बेंड होगी तो प्रेशर लॉस होगी. सो स्ट्रेट इज स्ट्रेट टाइप की नोजल इज यूज लाइक दिस स्ट्रेट टाइप. ओके, friction is in minimum possible, means as minimum as friction uh, is possible, means जितना कम सके उतना फ्रिक्शन मिनिमम करनी है. And these different type of abrasives are used according to uh, different applications. Okay, like aluminum oxide. Okay, so this aluminum oxide, the grain size. So this is actually the grid size, means the diameter of this means size of this particle or abrasive particle. Okay, इतना size average diameter. Okay, so this average diameter means grain size of aluminum oxide and different range like the 12 micron, 20 micron भी हो सकती है, 50 micron भी हो सकती है. Okay, and this aluminum oxide are used for mainly application of cleaning, cutting, and deburring. So deburring for, and these are used for hard material, brass and aluminium. Okay, for cutting brass and aluminium. Okay, also cleaning for also for cleaning this type of surface cleaning actually. Okay, another abrasive particle is like silicon carbide. So this silicon carbide, the grain size of this type of abrasive particles are two types: 25, either 25 microns and 40 microns. And these are used for very hard material like stainless steel or ceramic. Okay, so for cutting stainless steel and ceramic, so mainly for the hard material, this type of like silicon carbide abrasive particles are used. Okay, glass beads. Glass beads. So these type of abrasive particles are of 0.65 to 1.25 millimeter. And so this type of the size of grain size of this abrasive particles is more compared to this aluminum oxide and silicon oxide. They are in a in the range of micron, but in glass beads the range is in millimeter. Okay, and this type of abrasive particles are used for the applications of light polishing and fine deburring. Okay, means for the polishing of the surface, surface finishing. Okay, so this type of abrasive particles are used for surface finishing. Dolomite, so this grain size, grid size of this type means dolomite abrasive particles at 66 micron, and these type of abrasive particles are used for etching and polishing purpose. Okay, polishing means surface finishing. Sodium carbonate, sodium carbonate, this type of abrasive particles are the grain size is less, 27 microns, and these are used for light finish below 50 degree centigrade. Okay, so mainly for hard material. So for hard material like stainless steel or ceramics, these silicon carbide abrasive particles are used. Okay, okay. And for soft material like brass, aluminum, this aluminum oxide abrasive particles. Aluminum oxide abrasive particle for soft material, for cutting a soft material like aluminum and brass, this aluminum oxide abrasive particles are used. Okay, and for hard material like stainless steel and ceramics, silicon carbide abrasive particles are used. And other abrasive particles like glass beads, dolomite, and sodium carbonate. So these are used mainly for finishing, and so polishing and finishing. And so polishing and finishing of the on the surface of the material or okay. So these are different process parameters. You can change these parameters according to material removal rate. So how much material removal rate do you want? means, कितना material removal का जरूरत है. So according to that, these parameters like abrasive, means abrasive size, abrasive flow rate, okay, and abrasive material means किस type की abrasive material, abrasive means किस material की abrasive particle मैंने यूज करूँगा, कितना फ्लो रेट में abrasive particle को मैं मेंटेन करूँगा, कितना साइज से मैंने लूँगा. So is actually according to the material removal rate, means material removal rate कितनी है, according to that you can select different type of abrasive materials, different type of abrasive materials like aluminum oxide, Al2O3 is aluminum oxide, silicon carbide, glass beads. Okay, इस type की material आर्टिस जो है आर्टिस किस टाइप की मेटेरियल है, हार्ड है, सॉफ्ट है. ओके, एंड एब्रेसिव पार्टिकल्स यूज करूंगा उसका शेप, मीन्स इरेगुलर शेप है और रेगुलर शेप है. वो इरेगुलर शेप एक्चुअली मोर एफिशिएंट फॉर कटिंग पर्पस के लिए इरेगुलर शेप ऑफ एब्रेसिव पार्टिकल इज मोर more appropriate. And for finishing purpose, regular abrasive particle is more appropriate. Means the shape of the abrasive particle is regular type. Means, okay, this size of the abrasive particle can vary. Mass flow rate can also vary. Carrier gas. So carrier gas also and the process parameters. This means you can control the carrier gas. Means you can use either air or carbon dioxide or nitrogen. Okay, different type. This different different gases you can use. Oxygen actually not used. That I told. Because this oxygen can react with either abrasive particles or the artificial material. Okay, and chips of the artificial material. Okay, density कितनी होगी, velocity of the carrier gas means तो कैरियर गैस यूज करूंगा तो वेलोसिटी कितनी होगी। Pressure can vary. Okay, flow rate can also vary. So these are this carrier gas is one of the process parameter. Means by using different velocity, the material removal rate will be different. Means suppose velocity अगर ज़्यादा हो, then material ज़्यादा रिमूव होगी ना, सरफेस से ज़्यादा मटेरियल रिमूव होगी। ओके, अगर वेलोसिटी कम होगी तो मटेरियल कम रिमूव होगी। प्रेशर 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 वेरी द प्रेशर, अगर प्रेशर ज़्यादा होगी तो मटेरियल इजी रिमूव होगी, मीन मटेरियल रिमूवल रेट भी ज़्यादा होगी। फ्लो रेट भी अगर ज़्यादा है देन मटेरियल रिमूवल रेट भी ज़्यादा होगी। ओके, एब्रेसिव जेट मीन्स एब्रेसिव जेट जो इंक्रीज होगी द ऑर्किड, तो मीन्स इसका वेलोसिटी, स्टैंड ऑफ डिस्टेंस, ओके, इम्पिडेंट एंगल मीन्स कौन सी कितना एंगल से मैं इम्पिंज कर रहा हूँ। ओके, so all these parameters affect on the material removal rate in abrasive jet machining। ओके, वेलोसिटी मीन्स कितना रेट में मैंने कितना वेलोसिटी में इंक्रीज कर रहा हूँ। स्टैंड ऑफ डिस्टेंस मीन्स जो सरफेस है और पीछे सरफेस है, कितना कितना हाइट से मैंने, सपोज नोजल है, ओके नोजल है, तो इतना हाइट से मैंने इसको इंक्रीज कर रहा हूँ, तो दिस हाइट है एक्चुअली स्टैंड ऑफ डिस्टेंस। ओके, अगर मैं ज़्यादा हाइट से करूँगा तो मटेरियल रिमूवल रेट जो मिलेगी वो अलग होगी कंपेयर टू अगर स्टैंड ऑफ डिस्टेंस में घटाऊंगा। ओके, सो दिस स्टैंड ऑफ डिस्टेंस डिपेंड ऑन द मटेरियल रिमूवल रेट इन एब्रेसिव जेट मशीनिंग। ओके, इम्पिगमेंट एंगल, इम्पिगमेंट एंगल मीन्स जो नोजल नोजल आइदर नोजल जो यूज कर रहा हूँ, तो नोजल ऐसे स्ट्रेट है, मीन्स जस्ट परपेंडिकुलर है, और इसके साथ परपेंडिकुलर है, और नोजल इस तरीके से एंगल करके इम्पिंज हो रही है। ओके, सो दिस एंगल इज एक्चुअली इम्पिडेंट एंगल। ओके, so this actually vary from 60 to 90, means not more than 60 degree, not less than 60. So means this angle 60 to 90 degree, means more than 60 degree, not below 90 degree, means ऐसे इम्पिंज नहीं होगी। अगर 90 डिग्री मीन्स परपेंडिकुलर, नहीं तो मोर देन 60 डिग्री। ओके, so this angle should be more than 60 degree, more than, okay. Process capability, so material removal rate by this process, this abrasive jet machining is around 0.015 millimeter cube per minute, means per minute, uh, in a minute 0.015 centimeter cube volume material can be removed by this process. Narrow slot, so means by this process we can create a slot of zero point 0.1 to 0.12 to 0.25 mm, and in a tolerance of plus minus 0.12 mm. Okay. Surface finish, by this machining you will get a surface finish around 0.25 micron to 1.25 micron. Okay. So very good surface finish you can get by this machining process. Sharp radius up to 0.2 mm is possible. Means sharp radius means suppose suppose you want to make a groove, V groove, and here you want to make a radius. Okay, at the tip of the groove, here you want to make a radius. So by this machining, I up to 0.2 mm radius. up to means curvature of up to 0.2 mm radius, up to 0.2 mm radius is possible by this machining process. Okay, so this is actually not a very less amount, 0.2 mm. Steel up to 0.15 mm, glass up to 6.3 mm is possible to cut. And so this is actually thickness. And so steel of thickness of 1.5 mm thickness. And so means very thin sheet. 1.5 mm means thin sheet steel. And the glass, in case of glass, thick glass can cut by this process. Machining of thin section hard and brittle material is possible. Okay. So these are abrasive grain type and their size. So aluminum oxide. So these are different type of abrasives like aluminum oxide, Al2O3, silicon carbide, glass and sodium bicarbonate. Some abrasive. These are used in abrasive jet machining. So I've covered this what means different type of abrasive and their applications. Okay, aluminum oxide, silicon carbide, glass beads, dolomite, sodium bicarbonate. Okay, and there are different applications and uh, grain size or grid size of the abrasive particles. Okay. Carrier gas, so gas should be non-toxic, cheap, easily and available. This type of gas are used as air, nitrogen or carbon dioxide. Okay, gas may be supplied either from a compressor or a cylinder. Okay, I mean in case of a compressor, air filter from a dryer should be used to avoid the water or oil contamination of abrasive powders. Okay, so means if the gas supply is from either if the gas supply is a form of compressor, then a air filter dryer is required to avoid the contamination of the water and oil. Okay. The carrier gas consumption is in the order of 0.008 meter cube per minute. And per minute, this amount of gas will consume 0.008 meter cube at a nozzle pressure of 5 bar. Okay, means if the nozzle pressure is 5 bar, then per minute this amount of gas will consume. Okay, mixing ratio. So volume flow rate of abrasive and volume flow rate of gas. So this is the mixing ratio. Mixing ratio means how much volume flow rate of the abrasives, how much volume of abrasives are feeding uh, divided by volume flow rate of gas. Okay, and so uh, the gas is flowing from the compressor or cylinder, whatever. Okay, and in a mixture, both suppose this is the mixture. So here both gas and abrasive particle will mix. Okay, so the volume of abrasive particles means how much volume. So suppose V of abrasive particle, volume of abrasive particle V A. Okay. And the air volume of gas, mixing the volume of gas is V G. Okay. So this mixing ratio is V A upon V G. Okay. So this is actually mixing ratio. Okay. So this mixing ratio increase the mass flow rate of abrasive beyond a limit will result in a decreased velocity of flow. So just see material removal rate. So if you plot the material removal rate, this y-axis, and along this x-axis the mixing ratio. So if the mixing ratio will increase, then material removal rate will increase. Okay, मीन्स मटेरियल रिमूवल रेट ज़्यादा होगी, मीन्स जो वापिस मटेरियल है उससे ज़्यादा मटेरियल रिमूव होगी, मटेरियल रिमूवल रेट. Okay. So, but this material removal rate increases up to a maximum limit. Okay, and then again if you increase the mixing ratio, so from here if you again increase the mixing ratio, then this material removal rate will decrease. So this amount means this amount of mixing ratio is the optimum mixing ratio. Okay, so this is actually experimental comes. Some researchers have experienced that different maximum ratio, and they have observed that if the maximum ratio increase, then this material removal rate will increase up to maximum, and after then it will decrease. So this is actually optimum mixing ratio, optimum mixing ratio. After that mixing ratio will get the maximum material removal rate. Okay, and if you increase the flow rate of abrasive particle, the flow rate of abrasive particle, then this material removal rate increase linearly. Okay, and there is no this type of uh, uh, maximum limit and then falling down. Okay, so if you increase the abrasive flow rate, then material removal rate, okay, will increase linearly. Okay, next lecture इसके hello,
Yes, sir.
next lecture
राजकिशोर सर की है सर.
का क्लास लेंगे.
पता नहीं सर, लेंगे या नहीं लेंगे अभी तो.
लिंक भेजा है तो.
अभी तो आया नहीं सर. चेक करना पड़ेगा कॉल पोल पे.
ओके,
यस सर.
सर राजकिशोर सर का है अब
मैं पूछ के आ रहा हूँ राजू का क्लास लेंगे कि नहीं, अगर नहीं लेंगे तो मैं स्लाइड.
मैसेज आया है सर उनका
हाँ, मैसेज आया है.
उनका मैसेज आया है सर लेक्चर ज्वाइन करने के लिए.
ओके 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 ओके, थैंक यू. Then